Hi, my name is Jason Clark, and welcome back to South Dakota State University Extension and Nutrient Management topics that we cover here on this channel. Today, we've heard a lot of information in the past about soil health and other metrics measuring that. I just want to kind of go over what we're seeing across the nation and also what we're seeing here in South Dakota as far as different crop management systems and how they affect soil health. There's a lot about soil health, a lot of different definitions. I'll let you read the one that's sitting here behind me. But really what we want to look at is what does that soil health function perform? Biggest things we want to know is it helps regulate water. It sustains plant and animal life. It's a filter and buffering potential for pollutants. It helps cycle nutrients and provides physical stability and support for plants. So that's really what we want to know. We're first of all going to look at this nationally as seeing what types of systems, what types of management affect soil health concepts or measurements. So this is the North American Soil Health Project performed by the Soil Health Institute. This is just some of their research that they've come out with. They went to 124 long-term ag research sites, took 30 measurements and reported on them. And we'll look at some of them today. So some things they looked at were crop count, was more than one cash crop, rotational diversity, if they had only grains compared to other crops in the rotation, if they retained residue after harvest, if they added organic amendments to the soil, if they used cover crops, and also if they reduced tillage. So in this, we have lots of difference. At those 124 sites, you can see the different range here from residue retention of being on 14 to differences in decreased tillage on 51 of those 124 sites. So they have different numbers about the number of sites here, but this is what we're going to look at. So first of all, we're going to look at some carbon indicators. This first one is soil organic carbon. It forms the basis of soil, food, web, and biological activity. So if we look right here, we can see pretty quickly at the rotational diversity, we don't see a lot of effect. Crop count, not a lot of effect. If we really are looking for is difference from the zero, so we want these points to be over in this area. But once we start retaining residue, having organic amendments, and including cover crops and decreasing tillage, that's where we move the needle this way. On this other side of the line, we start seeing improvement in these soil health metrics. So this is true for soil organic matter, but we also see this same trend in about the same measurements, whether we look at per manganate oxidizable carbon, which is easily decomposable carbon. We see these same results, not a lot for rotational diversity or crop count, but once we go to adding organic nutrients, cover crops, decreased tillage, this is where we start to see the most, with the most coming from adding organic nutrients. So really what we're seeing is if we're adding organic nutrients, if we're adding residue, if we're adding things to the soil or keeping it on the soil surface, we're really improving these carbon measurements. Same thing with this water extractable organic carbon, we see those same trends. Now if we look at nitrogen indicators, here, with the nitrogen cycle, we're going to look at total nitrogen first. We see that same trend where rotational diversity and crop count don't do a whole lot to move that needle, but once we start keeping that residue on the soil surface, adding organic nutrients, cover crops, decreasing tillage, that's when we start to see this movement over here. This potentially mineralizable nitrogen, likely to be mineralized or become available to crops in the coming season, we see the same trend as well. Retaining residue, organic nutrients, cover crops, decreased tillage. So when you're adding manures, compost, anything like that, or keeping crops on the soil surface by not tilling it in, that's when we're increasing that mineralizable N capacity. Same thing with this A's protein, easily mineralizable N. We see that same trend here as well. Now the next question is, what does this look like in our state of South Dakota with the different trials that we've done? So I've done around 60 different nitrogen trials throughout Minnesota in this past 6 years, and we're going to look at some of those results. So we're going to look at conventional, well, the focus of this one is really looking at conventional tillage management versus no-till management. And here we already know inherently western part of the state, central part of the state, a lot more no-till, eastern side, wetter, not as much no-till, but still some on both in all areas. So we're looking at just organic matter here. We're going to have our responses over here. We have our central South Dakota and our eastern South Dakota here. We look at conventional till in central South Dakota versus conventional versus no-till. We see a higher organic matter in our no-till soils, so it's keeping that organic matter, it's not breaking down. In eastern South Dakota, we see kind of the reverse trend, maybe due to more conventional tillage being done or higher organic matters just in the eastern part of the state than the central. We see conventional till doing just as well as no-till here. We look at total nitrogen in the soil for central versus eastern. No-till has higher total nitrogen in that soil compared to conventional till. Not a huge amount, but it is higher. Eastern South Dakota kind of reverses, still not hugely different, but conventional till is a little higher on average. A's protein, easily mineralizable N, likely become available to the crop in the given year. Pretty similar, a little bit higher conventional than no-till. We kind of flip roles here, and we'll talk about this. This is easily mineralizable nitrogen. And then eastern side, also same trend. So before we talked about more long-term N. The long-term N and organic matter seems to be more abundant in no-till soils, less abundant in tilled soils. We'll give another example of that here in a second. If we're looking at organic carbon, so this is more long-term, all the carbon in general, no-till in central South Dakota is better than conventional till. Eastern South Dakota, it flips a little bit, but the numbers are much closer together. So this is more of a long-term, harder to decompose type of measurement. But then when we switch to the soil respiration, which measures biomass and activity, so easily decomposable minerals, how fast that is going on, we have same type of trend. We now flip back to conventional till in central South Dakota being higher than no-till, and also the same trend in eastern South Dakota. And a lot of this trend really has to do with the fact that when you're tilling, you're mixing that soil, you're adding oxygen in there. So now oxygen is no longer limiting as far as that breakdown of carbon, breakdown of nitrogen, and things like that become available to the plant. So when you add oxygen to the system, those tend to go higher. That's why our soil respiration, our ACE protein, and things like that are likely higher in conventional till compared to no-till soils. Whereas we're looking at our more long-term, harder to break down components, those tend to be higher in no-till soils compared to conventional till, especially in central South Dakota, where it's drier. So active carbon, again, easily decomposable microbes. So easily decomposable, quick to do so. This again shows conventional higher than no-till and central. And same thing in eastern South Dakota. So easily decomposable nutrients or activity microbes tends to be higher in conventional compared to no-till. So if we're looking at a summary of all this across these 64 sites, really to sum it up just kind of quickly here, we see that in the central part of the state, no-till has greater organic matter, greater carbon, and less easily decomposable carbon and nitrogen. Whereas in eastern South Dakota, we flip roles. The conventional till had more organic matter, more carbon, but also had more easily decomposable nitrogen and carbon, which at time you probably want a good amount of both, because we want carbon nitrogen to become available earlier in the season, but we also want it to become available later in the season. So we want probably maybe a little bit less, especially in some areas where nutrients can be limited, because we want it to become available later in the season when that crop needs it. So just because something's higher doesn't mean it necessarily that's healthier or better. We got to understand what that measurement means and how it's going to help in our overall cropping system and growing our crops. So thank you for joining me for this short review of some of our soil health metrics and how we're doing as far as tillage and things like that in South Dakota. If you have any questions, always feel free to reach out to me. And if you're interested in doing research on your farm, also reach out to me and see what we can do together. Thank you for your time.